right, so let me scroll up again, and let's have a conversation. So if this whole equation equals 0, what does that tell us about this piece? Well, the only way that I'm essentially adding two things together, two groups of things, and if I add two groups to things and the sum of the two groups is 0, that implies then that one of the things has to essentially equate with the other thing. But I'm going to set this 2c2 minus 2c1 plus c0 equal to 0. So that's sort of one of our facts about this. And then the other thing is we're going to focus on all those k statements, and those themselves are going to also equal 0. So k plus 2 times k plus 1, c to the k plus 2 minus k minus 2, k plus 1, c to the k plus 1, plus k plus 1, c to the k also has to equal 0. Okay, so up in the top one, and again, the logic here is you want to try to set the later term equal to the earlier terms. So if I take, I want to try to say, well, what does c sub 2 equal? What's that? Because that's the second term in the pattern is in with respect to the first two terms of the pattern. So if I solve for c2, I would get c sub 1 minus c sub 0 over 2. Okay, and then same argument with the others, but the second equation is I want to solve for the later pattern. So in that case, that would be c sub k plus 2. So if I move everything over, what kind of general equation do I get? So I'm going to have k minus 2, k plus 1, c sub k plus 1 minus k plus 1, c sub k, and each of these terms is going to be divided by k plus 2, k plus 1. And let's see, so I can clean that up a little bit because notice they both have a k plus 1 in them. So that's going to give me k minus 2 over k plus 2 c sub k plus 1 minus 1 over k plus 2 c sub k. And so the second equation right here, that's the one where we're going to start making our k patterns to see if we notice anything going on with the coefficients. So what kind of patterns do we notice, essentially? So let me kind of scroll down here. Yeah, I'm just going to copy down the two equations again.